Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry A-Levels Multiple Choice, Paper 11 from May-June 2018. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. This question refers to isolated gaseous atoms, in which atom are all electrons paired. Now you can solve this question by using electronic configuration. We have barium, bromine, sulfur and silicon. Now barium is from group 2 of the periodic table and it is a S block element. So its electronic configuration ends in NS orbital. Similarly, bromine is from P block. So its electronic configuration will end in NS and NP orbitals. For sulfur, we have again P block and its configuration will also be NS and P. For silicon, which is also in P block, electronic configuration is NS and P. Now let's look at the group numbers. Barium is from second group, so it has 2 electrons in the outermost shell. And as it is from 6th period, so it will be 6s2. Bromine is from group 7 of the periodic table, so the number of electrons will be 2 in S and 5 in P. So total electrons will become 7, where N is the number of period and bromine belongs to period 4. So it will be 4s2, 4p5. Similarly, S is in group 6, so number of electrons will be 6, 1, 2, and we have 4 electrons in p orbital, and as period number of sulfur is 3, so it will be 3s2, 3p4. Silicon belongs to group 4, so there are 2 electrons in s orbital and 2 electrons in p orbital, and the period number of silicon is also 3, so it will be 3s2, 3p2. Let's find out whether the electrons are paired or not. In s orbital we have 2 electrons, so these are paired, so this could be correct. In bromine we can see that electrons are paired in s orbital, but in p orbitals there are 5 electrons, so it means that we have 3 suborbitals, 4px, 4py, 4pz, and the number of electrons will be 1, 2, 3, 4, 5. So we have one unpaired electron left, so bromine is incorrect. Similarly, in sulfur we can see that there are paired electrons in s orbital, while in p orbital we have 4, so 3px, 3py, 3pz, and 1, 2, 3, 4 electrons, so there are 2 unpaired electrons, so this is also incorrect. In silicon again we have paired electrons in s while 2 electrons in p, so it will be 3px, 3py, and there is single electrons in each orbital, so we also have 2 unpaired electrons, so this is also incorrect. The only correct option having all electrons paired is barium. Question 2. Which compound has a boiling point that is influenced by hydrogen bonding? Now hydrogen bonding takes place in those molecules in which hydrogen atom is directly attached to one of the electronegative elements such as fluorine, oxygen or nitrogen. First one is aldehyde. We can see we have CH3, C double bond OH. As we can see, the hydrogen is not attached with oxygen, so A is incorrect. B is ether, so we have 2 carbon atoms which are bridged by oxygen, 3 hydrogen atoms with the first one, 3 with the second one. As we can see that oxygen is not directly bonded to hydrogen, so B also does not have hydrogen bonding. In C we have ester, HC double bond O, OCH3. No hydrogen is bonded directly with oxygen, so C is also incorrect. D is HCO2H, which is carboxylic acid. Now we can see that oxygen and hydrogen are directly bonded, so hydrogen will become partial positive, oxygen partial negative, and it will involve hydrogen bonding. The answer is therefore D. Question 3. Which fuel would produce the largest mass of carbon dioxide when 10 kilograms of the fuel undergo complete combustion? We have different fuels: biodiesel, ethanol, octane, propane. Let's find out the molecular masses of each of these. For C17H34O2, the molecular mass come equal to 270. For C2H6O, the molecular mass is equal to 46. For C8H18, it is equal to 114. While for C3H8, it is equal to 44. Let's find the number of moles. Moles is equal to mass divided by molecular mass. As mass is given as 10 kg, so the molecular mass is 270. The number of moles for biodiesel come equal to 37 moles. Similarly, dividing 10,000 with 46, the number of moles come equal to 217.39 moles. For octane, the number of moles is 87.72. For propane, the number of moles is 227.27. Now let's write balanced equation for the combustion reaction. We have C17H34O2 as it combusts in the presence of oxygen to give carbon dioxide and water. Let's balance the number of carbon atoms. As we have 17 carbon atoms on the reactant side, so we can balance by writing 17 with this CO2. So we can say that the ratio between biodiesel and carbon dioxide is 1:17 for number of moles. As we had 37 moles of the reactant, so for 37 moles, this much moles of carbon dioxide will be produced. So by cross multiplying, we can find the moles of CO2, which come equal to 629 moles of CO2. So we can write 629 with biodiesel. As we know that greater moles will mean greater mass, as mass is equal to moles into molecular mass, and molecular mass of carbon dioxide is fixed, which is 44. So greater number of moles would have greater mass in grams. Doing the same for ethanol, we have C2H6O. It combusts in the presence of oxygen to form CO2 and H2O. Let's balance carbon atoms. We have 2 carbon atoms on the reactant side, so we can write 2 with CO2. So the ratio is 1:2 in balanced equation. As we have 217.39 moles of reactant, so we can find the number of moles of carbon dioxide by cross multiplying. So X equals moles of CO2 that is formed, which equals 434.78 moles. So these many moles of CO2 are produced when 10 kilograms of ethanol is burnt in excess oxygen. For octane, we have C8H18. This is the combustion reaction. We can balance carbon by writing 8, so it is 1:8. So for 87.72 moles, it will be X. By cross multiplying, the number of moles of carbon dioxide come equal to 701.76 moles. So far this one gives greatest moles of carbon dioxide. Let's do the last one. We have propane, C3H8. To balance carbon, we have to write 3 with the product, so it is 1:3. So for 227.27 moles, it will be X. By cross multiplying, the number of moles of carbon dioxide produced is 681.81. Now you can find masses of carbon dioxide in each of the following by using mass is equal to moles into molecular mass, where molecular mass of carbon dioxide is 44 and the number of moles are given 629, 701 and 681. So as the greatest number of moles are in C, so therefore maximum mass would be produced by octane. The answer is C. Question 4. The diagram shows Boltzmann distribution of energies in a gas. The gas can take part in a reaction with an activation energy EA. The gas is maintained at constant temperature. Which statement is correct? This is the diagram. On y-axis we have molecules with a given energy, and on x-axis we have molecular energy, and this is the activation energy that is given. In all of the options given we have a catalyst being added. So we know that what does catalyst do is actually catalyst increases rate of chemical reaction by decreasing activation energy. Catalyst does not have any effect on the energy of molecules. It only decreases activation energy. So when catalyst is added, activation energy will move backward. So let's suppose this is the new activation energy that is with catalyst. Part A, if catalyst is added, peak P will be lower. This is wrong because there will be no effect on the average molecular energy. B, if catalyst is added, peak P will be lower. Again, this is incorrect. C, if catalyst is added, peak P will be the same and EA will move to the left. As now more molecules will be converted into products, so activation energy has decreased. So C is correct. D, if catalyst is added, peak P will be the same and activation energy will move to the right. This is incorrect because activation energy actually decreases. It does not increase. The answer is therefore C. Question 5. Which molecule has no overall dipole? If a molecule has an electronegative element and it has no overall dipole, it means that the molecule is symmetric in nature. Let's find out the symmetric among these, because all of them have chlorine atoms attached, which is electronegative element. A is CH3Cl, so we have 3 hydrogen atom and 1 chlorine atom. So this molecule is polar, so therefore it has some dipole. B is CH2Cl2. Again we can see that electronegative chlorine atom is attached and electropositive hydrogen atom is also attached. So this molecule also has an overall dipole. In C we have 1 hydrogen atom and 3 chlorine atoms. Again we have partial negative charges on this side, while less electronegative element is attached on the back side, so therefore this is also polar and it has dipole. In D we have all hydrogen atoms replaced by chlorines. So now the structure is tetrahedral, and as we know that there is symmetric arrangement of electronegative element around the central atom, so dipole will be cancelled out and overall dipole will be equal to 0. The answer is therefore D, as it is symmetric molecule. Question 6. Which solid contains more than one type of bonding? We have iodine. Now iodine consists of I2 with covalent bond. When iodine is solid, what happens that these molecules come close together with intermolecular forces of attraction, making it solid. So two types of bonding are present. One is covalent bonding and second is intermolecular forces of attraction in solid iodine. So A could be correct option. B is silicon dioxide, which is giant covalent in nature. In silicon dioxide, each silicon is attached with 4 oxygen atoms directly, and each oxygen atom is then attached with 2 silicon atoms directly. And this structure goes on and on. So therefore only one type of bonding is present, which is covalent bond. C is sodium chloride. Sodium chloride is giant ionic in nature, as each sodium is surrounded by negative chloride ion. and each chloride ion is surrounded by positive sodium ions. So only one type of electrostatic forces of attraction is present, which is ionic bonding. In D we have zinc. Zinc is a metal and it is also an element. Only metallic bonding is present in zinc metal. So solid iodine does have two types of bonding, while all others have only one type of bonding. Question 7. Enthalpy changes of combustion can be used to determine enthalpy changes of formation. The following equation represents the enthalpy change of formation of butane. 4 moles of carbon reacts with 5 moles of hydrogen to form 1 mole of butane, which is gas. By using the following standard enthalpy of combustion data, what is the value of standard enthalpy change of formation of butane? We can apply Hess's law to find out the enthalpy change of formation, as this is the equation. We have carbon solid that reacts with hydrogen gas to form C4H10. The enthalpy change of formation is to be found as 1 mole of product is being formed from its reactants in their standard states. Now let's introduce combustion. For carbon combustion, the product is carbon dioxide, and for the combustion of hydrogen, the product is water. So combustion can take place of element. It can also take place for this product, which is butane. As balanced number of carbon atoms, we have 4 carbon atoms now balanced, 5 with H2O, so hydrogen is also balanced. We do not need to balance oxygen atoms. This is delta H1, which involves combustion of carbon and combustion of hydrogen to form carbon dioxide and water. This is delta H2, which includes combustion of C4H10. According to Hess's law, this is a two-step reaction, as elements are first converted into reactant and then reactant is combusted to form product. And this is one-step reaction, as elements are directly converted into combustion products. Let's put values. For delta H1, we have combustion of carbon, as there are 4 moles for carbon, so we can multiply 394 with 4. It comes equal to minus 1576 kilojoules per mole. Similarly, we have 5 moles of hydrogen, so we can multiply this value with 5. So it comes equal to minus 1430. Now adding these two, the total enthalpy change in delta H1 will be equal to minus 3006 kilojoules per mole. Now in delta H2, we can see that only 1 mole of C4H10 is being combusted, so the value will be as it is. So it is negative 2877 kilojoules per mole. Let's make an equation. One step is equal to the sum of two steps. Putting values, for delta H1 we have minus 3006. Delta HF is yet to be found. Delta H2 value is negative 2877. So delta HF will be equal to minus 3006 plus 2877, which equals minus 129 kilojoules per mole. So this means that B is the answer. Question 8. Ethane dioate ion C2O4 negative 2 reacts with suitable reagent to form CO2. A half equation for this reaction is shown. Ethane dioate converts into carbon dioxide and loses 2 electrons. Which row is correct? First, we have to find out the oxidation state of carbon in C2O4 negative 2. And second, we have to find the type of reaction, whether it is oxidation or reduction. Let's first find out the oxidation state of carbon in C2O4 negative 2 and in CO2, which is the product. As we have 2 carbon atoms, 4 oxygen atoms, and overall charge is negative 2. So for 1 oxygen, the oxidation state is negative 2. For 4, it will be negative 8. So 2C will be equal to plus 6, or 1 carbon will be equal to plus 3. So the oxidation state of carbon is plus 3 in ethane dioate ions. So it could be A or B. Now in CO2 we have 1 carbon atom, 2 oxygen atoms and overall charge is 0. So C minus 4 equals 0 or C equals plus 4. So oxidation state of carbon in product is plus 4. As we can see that there is increase in oxidation state, so therefore this is oxidation. The answer is therefore A. Question 9. Oxidation numbers should be used to answer this question. A redox reaction takes place between hydroxyl ammonium ions, which is NH3OH positive, and acidified iron 3. The products are iron plus 2, H plus, water and a compound of nitrogen. The mole ratio of reacting hydroxyl ammonium ions to reacting iron 3 ions is 1:2. Which nitrogen containing compound could be formed in the reaction? We have hydroxyl ammonium ions, which is NH3OH, and overall charge is positive. It converts into nitrogen containing compound, which is to be found. In second half of the equation we can see that iron plus 3 are converted into iron plus 2. The mole ratio of hydroxyl ammonium ions to iron plus 3 ions is given. It is 1:2. So if 1 mole of this compound is present, then 2 moles of iron plus 3 is present. Let's balance the second equation. We have 2 moles of iron plus 3 on the reactant side. So we have 2 moles of iron plus 2 on the product side. Also iron plus 3 converts into iron plus 2 by gaining electrons. So 2 electrons are gained. As this is redox reaction, so this portion is the gain of electron, which is called reduction. So second part must be oxidation. In oxidation we have loss of electrons. As we can see that 2 electrons are gained, so the number of electrons lost and gained should be equal. So it means that in first reaction 2 electrons were lost. Let's find out the oxidation state of nitrogen in the reactant side, and also we can find out the oxidation state of nitrogen given in these compounds. First one is NH3OH and overall charge is plus 1. As we have 1 nitrogen, 4 hydrogen atoms, 1 oxygen and overall charge is plus 1. The oxidation state of hydrogen is positive, so we have plus 4 for 4 hydrogen atoms, negative 2 for 1 oxygen. So nitrogen plus 2 equals plus 1, or nitrogen will be equal to minus 1. So we can write the oxidation state of nitrogen in the reactant, it is negative 1. Now finding the oxidation state of nitrogen in NH3, as nitrogen is more electronegative, so the oxidation state is minus 3. In NO2 we have 2 nitrogen atoms, 1 oxygen atom, so the oxidation state of each nitrogen is plus 1, as nitrogen is less electronegative than oxygen. For NO the oxidation state of nitrogen is plus 2. In NO2 the oxidation state of nitrogen is plus 4. As we can see that in this equation 2 electrons were lost. So when 2 electrons are lost by nitrogen atom, it will form negative 1 to positive 1 oxidation state. As we can see that the oxidation state is positive 1 in N2O, so it must be N2O. Now we can write the overall balanced equation. We have 1 mole of NH3OH positive, 2 moles of iron plus 3. The number of electrons lost and gained is cancelled out. Product is N2O. Second product is Fe plus 2. We also have H plus water. As irons are already balanced, so we have 2 moles of irons in each. The mole ratio was given, which is 1:2. So this reactant must be 1 mole. Now to balance nitrogen, we must write half with N2O to balance nitrogen atoms. Let's find out the positive charges. We have iron plus 3 and there are 2 moles, so total positive charge is +6 for iron +3, and we also have positive charge on this compound, which is 1 mole, so +6 + 1 equals +7. So we have +7 charge on the reactant side, and we have +4 charge on the product side, so we can balance the number of charges by adding 3 with H+, so that it also becomes +7. As we can see, we have 4 hydrogen atoms on the reactant side, 3 hydrogen atoms are balanced, so we can write half with H2O to balance hydrogen atoms. The oxygen atoms are already balanced, so now this is the balanced redox equation. The answer was B. Question 10. Element X has higher first ionization energy than element Y. Two students state what they believe is one factor that helps to explain this. Student 1 says that X has higher first ionization energy than Y because an atom of X has more protons in its nucleus than an atom of Y. Student 2 says that X has higher first ionization energy than Y because X has smaller atomic radius than Y. Only one of the students is correct. What could X and Y be? Now we have two students. One is first one and other is second one. Let's find out which student is correct for which option. First one is carbon and boron. Now the atomic number of carbon is 6 while that of boron is 5, and both are present in same period of the periodic table. So we know that when we move from left to right in the periodic table, the ionization energy increases. So it means that carbon has more ionization energy as compared to boron. This is because atomic number increases and the force of attraction between the nucleus and outer electrons also increase, and also size of atom decreases. So it means both students are correct. In B, we have magnesium and aluminum. The atomic number of magnesium is 12 while that of aluminum is 13. Now in magnesium, the electronic configuration is 1s2, 2s2, 2p6, 3s2. While in aluminum, the electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p1. As we can see that the outer electron in aluminum is farther from the nucleus as compared to magnesium. So the ionization energy in aluminum will be lower than magnesium. So X will be higher and Y is lower. Let's look into the first reason. Because an atom of X has more protons in its nucleus than an atom of Y. As we can see that the number of protons are less in magnesium as compared to aluminum. So first student is wrong. For second student, we can see that the reason is that X has a smaller atomic radius than Y. Now this student is also wrong because as atomic number increases, the size of atom decreases, so magnesium is larger as compared to aluminum. So both students are incorrect. In C, we have oxygen and nitrogen. The atomic number of oxygen is 8, while for nitrogen it is 7. The electronic configuration of oxygen will be 1s2, 2s2, 2p4, while in nitrogen it will be 1s2, 2s2, 2p3. In 2p4 we have pairing of electrons. As there are 4 electrons, so we have 2 in the first, 1 in the second and 1 in the third. The electron removed first will be this one, as it is present in spin pair repulsion, so it means there is repulsion between electrons, due to which its ionization energy will be less. While in nitrogen we have 2p3, so it means each electron is present as separate. So no electron pair repulsion is present, so therefore nitrogen's ionization energy will be higher. As both students said that X has higher first ionization energy, which in this case is wrong. In D, again we have oxygen whose atomic number is 8, and sulfur whose atomic number is 16. So we can do electronic configuration. For oxygen it will be the same. For sulfur it will be 1s2, 2s2, 2p6, 3s2, 3p4. As we can see that in oxygen, outer electron is removed from 2p orbital, while in sulfur it is removed from 3p orbital. So as 2p orbital is nearer to the nucleus as compared to 3p orbital, so therefore ionization energy in oxygen will be higher than sulfur. So both students are correct. Now let's move to the reason. First student says that it is because an atom of X has more protons in its nucleus than an atom of Y. As we can see that oxygen has less protons in its nucleus as compared to sulfur, so student 1 is incorrect. Now second student gives the reason that because X has a smaller atomic radius than Y. As we can see that the atomic size of oxygen is less than sulfur, so student 2 is correct. So the only option in which one of the student is correct is D. Question 11. Hydrogen ions catalyze the hydrolysis of esters. Which statement is correct? A. The hydrogen ions act as a heterogeneous catalyst. Let's find out whether it is homogeneous or heterogeneous. In hydrolysis of esters, we have ester which is liquid, water which is also liquid, H plus ions which are in aqueous form, as we can see that the state of catalyst which is aqueous is same as the state of other reactants. So therefore this is homogeneous catalysis, it is not heterogeneous. This is because hydrogen ions are in same phase as the reactants, so B is correct. C. The hydrogen ions are used up in the reaction as H plus ions catalyze the reaction, so we know that catalyst is not used up in the reaction. Also we know that catalyst decreases the activation energy, so it says it has no effect on the activation energy, so therefore D is wrong. Correct answer is therefore B. Question 12. Silicon is heated in an excess of chlorine producing compound J. Excess water is added to sample of J produced. Which row is correct? First you have to find the structure of J. Second you have to find whether HCl is produced when water is added to J or not. Let's find out the product. Silicon when reacts with excess chlorine, it will form silicon chloride, SiCl4, which is compound J. Now SiCl4 when added to water, what happens that it gets hydrolyzed and along with silicon dioxide it forms white fumes of HCl. The reaction is very rapid. Let's find out the structure of SiCl4. In SiCl4 we have one silicon attached with 4 chlorine atoms. So it is a simple molecular structure, it is not giant molecular. And as HCl is produced in the product, so therefore this is a gas. The answer is therefore D. Question 13. Which element has the second smallest atomic radius in its group and third lowest first ionization energy in its period? Let's first find out the groups of these elements. First is boron. Boron is in group 3. We have boron, aluminum, gallium, indium. As we know that the atomic radius increases down the group, so boron is the one having smallest atomic radius, so it is not the second smallest, it is the first one, so boron is incorrect. Second is calcium. Calcium belongs to group 2 of the periodic table. So in group 2 we have beryllium, then magnesium, then calcium. So as we can see that calcium is on third number. So it has the third smallest atomic radius. So it is not calcium. For magnesium, it is in group 2 of the periodic table and we can see that it has second smallest atomic radius. So it could be magnesium. Last one is sodium. In first group we have lithium, then sodium. So it is in second number. So therefore it could also be sodium. Now let's find out the ionization energy in its period. We have sodium, magnesium. Both belong to period 3 of the periodic table. So we have sodium, magnesium, aluminum, silicon, and so on. The atomic number of sodium is 11, for magnesium it is 12, for aluminum it is 13, then 14, and so on. Let's do the electronic configuration. For 10 electrons we know it is 1s2, 2s2, 2p6. Then for the 11th electron it will be 3s1. For magnesium it will be 3s2, as we have 12 electrons. For aluminum it will be 3s2, 3p1. For silicon it will be 3s2, 3p2. As a general trend, we know that when atomic number increases, the ionization energy also increases, as long as the electrons remain in the same shell. So as in period 3, the number of shells do not change, so overall ionization energy will increase. So sodium has the lowest ionization energy, lowest first. In magnesium the atomic number is 12, so as the number of protons and electrons increase, so ionization energy will become higher as compared to sodium. So we can say that if this is the first ionization energy of sodium, then this will be the first ionization energy of magnesium. For aluminum, we can now see that the electron will be removed from 3p orbital instead of 3s orbital. As we know, the 3p orbital is farther from the nucleus as compared to s orbital, so first ionization energy will decrease. So for aluminum it will be at this place. Then we have silicon, and as number of protons increase, the number of electrons also increase, and we have same p subshell, so therefore ionization energy will increase. So we can say that sodium has the first lowest, then we have aluminum which has the second lowest ionization energy, then magnesium which has the third lowest ionization energy. So the answer is C. Question 14. Chlorine reacts with cold aqueous sodium hydroxide to produce sodium chloride, water, and compound X. Chlorine reacts with hot aqueous sodium hydroxide to produce sodium chloride, water, and compound Y. What are the oxidation states of chlorine in compound X and compound Y? Now in cold sodium hydroxide, what happens that the compound containing chlorine and oxygen is NaClO, which is formed, while in hot aqueous sodium hydroxide the compound formed is NaClO3. Let's find the oxidation state of chlorine in each. We have sodium whose oxidation state is +1, then we have chlorine, then one oxygen whose oxidation state is -2, overall charge is 0. So chlorine -1 equals 0, so chlorine equals +1. So it is +1 for chlorine. In NaClO3 we have +1 for one sodium, then chlorine, then we have 3 oxygen atoms, so oxidation state is -6, overall charge is 0. So chlorine -5 equals 0, chlorine becomes +5. So it is +5 for Y. The answer is therefore D. Question 15. In which reaction does ammonia behaves as Bronsted-Lowry base? Now you should remember that Bronsted-Lowry base is proton acceptor. In A we have NH3 and then it changes into NH2, so one hydrogen is lost, so therefore this is not behaving as Bronsted-Lowry base. In B we have NH3 and then it changes into NH4, ammonium bicarbonate, so the charge on NH4 is +1. So from NH3 we know that it had one lone pair of electron which was given to H+ to form NH4+. So as it is accepting a proton, so therefore in B it is behaving as Bronsted-Lowry base. In C we have NH3 and then it has converted into NH2, so again it has lost hydrogen, which is incorrect. In D we have NH3 that has converted into N2, so it has lost all its hydrogen atoms. So this is also not the definition of Bronsted-Lowry base. The answer is therefore B. Question 16. Aqueous silver nitrate is added to solution of potassium iodide. Aqueous ammonia is then added. What would be observed? Now we know that when silver nitrate is added to potassium iodide, it forms silver iodide precipitate, which is pale yellow in color. And this precipitate remains insoluble in aqueous ammonia and even in concentrated ammonia solution. So a yellow precipitate is formed that does not dissolve on addition of aqueous ammonia. The answer is therefore D. Question 17. Oxides of nitrogen are present in the environment due to natural and man-made sources. Which row is correct? First is the natural source and second is the man-made source. A is electrical discharges in the atmosphere. Now we know that the bond in nitrogen is very strong and the bond in oxygen is also very strong. So in order to form nitrogen oxides, a lot of energy is required to break this bond and break this bond too. So therefore electrical discharges can do that, for example lightning. C and D is the decomposition of dead plants in rivers. This produces methane gas, it does not produce nitrogen oxides. Now moving towards man-made sources. In internal combustion engines of cars, what happens that the temperature is very high and nitrogen from air and oxygen can convert into nitrogen oxides. So this is true. Second is as a byproduct of the Haber's process. In Haber's process, ammonia is formed from nitrogen and hydrogen. No nitrogen oxides are formed as a byproduct. So this is incorrect. Correct answer is therefore A. Question 18. When 3 grams of an anhydrous nitrate of group 2 metal is decomposed, 1.53 grams of gas is produced. What is the nitrate compound? Now the formula of group 2 nitrates is MnO3 2. Let's find out the molecular masses of all these 4. As in nitrate we have 2 nitrogen atoms, 6 oxygen atoms. So the molecular mass equals 124 for nitrates. For beryllium the atomic mass is 9, so 9 plus 124 equals 133. For calcium the atomic mass is 40.1, so 41.1 plus 124 equals 164.1. For magnesium the atomic mass is 24.3. So it becomes equal to 148.3. For strontium the atomic mass is 87.6. So it comes equal to 211.6. Now let's write a balanced chemical equation for decomposition of group 2 nitrates. So we have metal nitrate of group 2. It decomposes to form metal oxide, nitrogen dioxide and oxygen gas. We can balance this equation by writing 2, 2, 4 and 1. Or you can also simplify the ratio by writing 1, 1, 2 and 0.5. As we know that only NO2 and O2 is the gas, metal oxide is solid, so we have to consider these 2 moles and this one. Let's find the number of moles of the reactant. The mass is 3 grams. So as number of moles is equal to mass in grams divided by molecular mass. So 3 divided by 133 will be equal to 0.0225. Similarly for calcium nitrate, the number of moles in 3 grams will be equal to 0.0183. For magnesium nitrate it is 0.020. For strontium nitrate, it will be 0.0142. Now starting with the first one, we have beryllium nitrate whose number of moles is 0.0225. As we know that for 1 mole, 2 moles of NO2 are produced. So for 0.0225, 2 into 0.0225 moles of NO2 will be produced, which is equal to 0.045 moles. Let's find the mass of NO2. The molecular mass is 14 plus 32, which is equal to 46. So mass in grams is equal to moles into MR, as moles is 0.045 and molecular mass of NO2 is 46. So mass in grams come equal to 2.07 grams. As the combined mass of these two gases was given as 1.53, so it is less than our value, so it means it is not beryllium nitrate. Let's do the same for calcium nitrate. We have 0.0183 moles. So for NO2 it will be doubled, which equals 0.0366 moles. Now converting it to mass into moles into MR. The mass in grams come equal to 1.683 grams. Again 1.683 is greater than 1.53, so therefore B is also wrong. Now doing the same for magnesium nitrate, as the number of moles is 0.020, so NO2 will be doubled. Now finding mass. Again this is greater than the given amount, so it is also incorrect. Now doing the same for D, as we have 0.0142 moles, so the number of moles of NO2 will be doubled, 0.0142 into 2, which equals 0.0284 moles of NO2. And for oxygen the number of moles will be half, as it is 1:0.5, so 0.0142 divided by 2, it comes equal to 0.0071 moles. Let's find out the mass. Mass is equal to moles into MR. So it comes equal to 1.306 grams of NO2. Similarly for oxygen, the mass equals moles into molecular mass of oxygen, which is 32. So it comes equal to 0.2272 grams of oxygen. Now combining both of these gases, we have 1.306 plus 0.2272. So it comes equal to 1.533 grams. Now this is exactly equal to the value given in the question, so therefore D could be correct. The answer is therefore D. Question 19. Which row correctly describes one property of barium and one property of barium oxide? First one is the observation when barium metal is added to water. Second is pH of solution obtained when a spatula measuring of barium oxide is added to water. As we know that barium is in group 2 of the periodic table, and we have beryllium, magnesium, calcium, strontium, barium. And we know that reactivity increases down the group as loss of electrons become easier. So what will happen, that rapid reaction will be seen with water. As hydrogen gas is produced, barium plus water, it forms barium hydroxide and releases hydrogen gas. So rapid effervescence is seen for hydrogen. Second is the pH of solution when barium oxide is added to water. When barium oxide is added to water, it is soluble, it forms barium hydroxide and the pH will be greater, so it is 13. This is because solubility of oxides of group 2 also increases. The answer is therefore D. Fructose is a sugar with more than one chiral center. The fructose molecule is shown with X, Y and Z, indicating 3 carbon atoms. This is X, this is Y and this is Z, which carbon atoms are chiral centers. Now we know that carbon is chiral, which is attached to 4 different elements or groups. Directly. First is X. We can see we have H, OH, this whole group and this group that is below. So this one is chiral, so X is chiral. Then we have Y. Again we can see we have OH group, H group, this whole group attached and this group, as all 4 are different, so Y is also chiral. For Z we can see that 2 similar atoms are present with carbon, so therefore Z is not chiral. As only X and Y show chiral, so therefore answer is B. Question 21. Which pair of alcohols are isomers of each other? Now isomers means those compounds that have same molecular formula but different structures. In A we have butane 1-ol, so in long chain we have 4 carbon atoms for butane, and on first carbon we have alcohol group attached. Rest of the number of hydrogen atoms. So the molecular formula is C4H10O. Second is 2,2-dimethylpropane 1-ol, so in long chain we have 3 carbon atoms as it is propane, and on second carbon we have 2 methyl groups attached, while on first carbon we have alcohol group present. Rest are the number of hydrogen atoms. The molecular formula is C4H12O. As we can see, molecular formula is different, so A is incorrect. In B we have butane 2-ol. We have 4 carbon atoms in butane, and on second carbon atom we have OH functional group. Rest are the number of hydrogen atoms. The molecular formula is C4H10O. Second is 2-methylpropane 2-ol. As we have propane, so there are 3 carbon atoms in the long chain. On second carbon we have methyl group and also OH group. Rest are the hydrogen atoms. The molecular formula is C4H10O. As we can see, the structure is different and the molecular formula is same, so therefore B could be correct. For C we have pentane 1-ol and 2-methylpropane 2-ol, as this is the same one. Let's draw the structure of pentane 1-ol. In pentane we have 5 carbon atoms in long chain, and 1-ol means OH is attached with the first carbon. As we can see that the number of carbon atoms are 5, while in 2-methylpropane 1-ol the number of carbon atoms is 4. Therefore these are not isomers. In D we have propane 2-ol. In propane we have 3 carbon atoms, and on second carbon we have OH group attached. Molecular formula is C3H8O. As number of carbon atoms and hydrogen is different, so therefore D is also not isomer. Correct answer is therefore B. Question 22. Sodium methoxide Na plus CH3O negative reacts with 2-chloro 2-methylpropane in a nucleophilic substitution reaction. The nucleophile is this one. Which row is correct? First you have to find out the intermediate or transition state, and then you have to find out the product. Let's first draw the structure of 2-chloro-2-methylpropane. So in long chain we have 3 carbon atoms as it is propane. On second carbon we have chloro, and we also have methyl group attached. As we can see that the electronegative chlorine is attached with this carbon atom, which is directly attached with 3 alkyl groups, so therefore this is tertiary halogenoalkane. And in tertiary halogenoalkane, nucleophilic substitution reaction takes place in such a way that this compound is first converted into this product, which is carbocation. And then in second step, CH3O negative will attack this carbon and form product. As all these methyl groups are similar, so we can write CH3 tries. Then we have carbon and oxygen. Then we have CH3. So now the intermediate formed is this one, which shows this. The product formed is this one, which is equivalent to this product. The answer is therefore A. Question 23. Which alcohol can be dehydrated to give 2 products which are structural isomers of each other? Now dehydration means removal of H2O. As we have alcohol, so from one carbon atom OH will be removed, from adjacent carbon hydrogen atom will be removed. Similarly from this, OH is removed from this carbon, and hydrogen atom can be removed from this carbon which is adjacent, or from this carbon which is also adjacent. Similarly in C we have OH group that is removed from this carbon atom, and hydrogen is removed from adjacent carbon. In D again we have OH which is removed from this carbon, and this carbon is adjacent, this is also adjacent, and this is also adjacent. First one is A, so the product form will be like this. OH is removed from last carbon, we only have 2 hydrogen atoms left, while 1 hydrogen is removed from this carbon atom. Rest the number of hydrogen is same. This is but1ene, and this is the only product that is formed by dehydration of A, so therefore A gives only one product. In B we can remove OH from this carbon and hydrogen from this carbon, then the product will be like this. We have CH3, CH2, then this carbon with just 1 hydrogen left. OH is removed, and this carbon atom having 2 hydrogen atoms. As the double bond is between first and second carbon, so it is but1ene. Now removing OH from this carbon atom and hydrogen from adjacent carbon atom, the product form will be like this. CH3, CH, double bond, CH, CH3. Now the double bond is between second and third carbon atoms, so the product will be but2ene. Let's find out the molecular formula. The molecular formula is C4H8. For this one, the molecular formula is C4H8. So B produces 2 products upon dehydration, and both are structural isomers, so therefore B could be correct option. In C we can remove OH from this carbon atom and hydrogen from this carbon atom. The product will be like this. CH3, C double bond CH, 2, CH3. As we have 3 carbon atoms in the long chain, and double bond is present between first and second, and methyl group is present on second carbon atom, so the name will be 2-methyl prop1ene. As only one dehydration product is formed, so therefore C is incorrect. In D, we can remove OH from this carbon atom and hydrogen from this carbon. The product will be CH3, C double bond CH2, CH3. As we have 3 carbon atoms in the long chain including double bonded carbons, so the product will be 2-methyl prop 1-ene. Now if we remove OH from this carbon and hydrogen from this carbon, then the product will be like this: CH3, C, CH3, double bond CH2. Again we have 3 carbon atoms in the long chain including double bond. On second carbon atom methyl group is attached, so it will be 2-methyl prop 1-ene. As the naming is same, so therefore these two products are actually same product. In third scenario, we can remove OH from this carbon atom and hydrogen from adjacent carbon. So the product will be CH2, double bond C, CH3, CH3. Again we have 3 carbon atoms in the long chain. Double bond is present between first and second carbon and CH3 is attached with the second carbon, so it will be 2-methyl prop 1-ene. As similar product is formed upon dehydration, so therefore these are not the isomers, these are actually same product. So D is incorrect. The answer is therefore B. Question 24. Which reagent could detect the presence of alcohol in a mixture consisting mainly of alkanes and alkenes? First one is sodium. Now sodium can react with alcohol to form sodium alkoxide. Along with the production of hydrogen gas. Whereas sodium does not react with alkanes and alkenes, so therefore A could be correct. B is bromine in CCl4. Now bromine can be added to alkenes, so therefore it can be used to identify alkenes, as bromine will be attached with the double bonded carbon atoms to convert it into dibromoalkane, and bromine is itself decolorized. So it cannot detect alcohols, it can detect alkenes only. C is CaMnO4, which is oxidizing agent. Now this can oxidize alcohol into aldehyde and carboxylic acid. CaMnO4 can also oxidize alkenes to diol. So it cannot differentiate between alcohol and alkene as it will react with both. So therefore C is wrong. D is 2,4-dinitrophenylhydrazine, which is also called 2,4-DNPH, and it can be used for the identification of aldehydes and ketones. As no aldehyde and ketones are present in this mixture, so therefore D is wrong. Only sodium can be used to identify alcohols in the mixture of alkanes, alkenes and alcohol. Question 25. Compound Q contains a chiral center, gives positive result with valence reagent, gives positive result with alkaline aquaciodine. What could compound Q be? A is 1-hydroxybutanone. We have 4 carbon ketone. On first carbon atom hydroxy group is present. Ketone can be on third carbon or on second carbon. Rest are the number of hydrogen atoms, so 2 hydrogen with this one, 2, 3, 2, 2, 3. Let's first find chiral center. As we can see that there is no carbon that is attached to 4 different elements or groups, so therefore we don't have chiral center. B is 2-hydroxybutanol. Again we have 4 carbon aldehyde, 1, 2, 3, 4, and as it is aldehyde, so it is C double bond OH. On second carbon atom we have hydroxy. Rest are the number of hydrogen atoms. As we can see that this carbon is attached to 4 different groups, OH, this one, hydrogen and COOH, so therefore this is chiral carbon, so it does contain a chiral center. Second is it gives a positive results with valence reagent, as this is aldehyde, so aldehyde give positive result with valence reagent, so this is also true. Third one is it gives a positive result with alkaline aqueous iodine. Now it is triiodoform test, and for triiodoform there must be a CH3 group directly attached with carbonyl carbon. As we can see that with carbonyl carbon CH3 is not attached, so therefore it won't give this third result. So B is incorrect. C is 3-hydroxybutanol. Again we have 4 carbon aldehyde. This time hydroxy group is attached with the third carbon. Rest are the number of hydrogen atoms. As we can see that this carbon is attached to 4 different groups. One is OH, one is H, one is CH3 and one is this one. So therefore it is chiral center. Second, it can also react with valence reagent as it is aldehyde. For third reaction, as we can see that CH3 is directly attached with the carbon atom having OH group. Now this can also be a positive result for triiodomethane. If this CH3 is directly attached with the carbon atom having OH group, then this result will be positive. As we have CH3 with this carbon which is also attached with OH, so it will give positive result with alkaline aqueous iodine. So C could be correct. In D we have 3-hydroxybutanone, as it is known, so it means it is ketone of 4 carbon atoms. On third carbon we have OH, as it is 3-hydroxy. Rest are the number of hydrogen atoms. We do have chiral carbon, as it is attached with 4 different groups. As it is a ketone, so it will not give positive result with valence reagent. And also we can see that CH3 is directly attached with carbon atom having OH, so then it will give a positive result with alkaline aqueous iodine. But as second test is not given, so therefore D is wrong. Correct answer is therefore C. Question 26. What is the mechanism for the reaction of ethanol, which is aldehyde, with hydrogen cyanide in the presence of sodium cyanide? Now in B we can see that this is ethanol, as it is aldehyde. In first step, cyanide will attack partial positive carbon atom, and this double bond will be converted into single bond and electrons will move towards oxygen. Now this CN is attached. And now oxygen will attack this hydrogen in HCN, and electrons will move towards CN to form cyanide ion, and hydrogen is attached with oxygen. Now in product form we can see that HCN has been added upon carbonyl carbon, and also we can see that cyanide ion behaves as a catalyst, as it is present in the reactant and the product. So this is the correct mechanism for this chemical reaction. The answer is therefore B. Question 27. Ethyl propanoate is refluxed with aqueous sodium hydroxide. The alcohol produced is then reacted with methyl propanoic acid to make a second ester. What is the structural formula of this second ester? Let's first draw the structure of ethyl propanoate. When it is refluxed with aqueous sodium hydroxide, the product formed is like this. The portion with carbonyl will become sodium salt of carboxylic acid, while the other portion will become alcohol. So the product formed is CH3CH2, C double bond O, O negative, sodium positive. So this is sodium salt of carboxylic acid. And also ethanol is formed. Now this product, which is ethanol, it can react with methyl propanoic acid to make second ester. Let's draw the structure of methyl propanoic acid. In propanoic acid we have 3 carbon atoms. When methyl is attached, it means it is on this carbon atom. So this will react with this ethanol in such a way that water will be formed from this OH and H, and rest of the compounds are combined together to form ester. The product will be like this. After this we have this oxygen, then this carbon, and then this CH3. This is the second ester that is formed. Among the given options, we can see that this is similar to this portion, and CH3CH2 is also present with the oxygen, so therefore A is correct. Question 28. Which reagent could be used to carry out the following reaction? Now in this reaction we have alkene functional group, which is unchanged, and aldehyde functional group is changed into carboxylic acid. A solution containing acidified dichromate ions. Now dichromate 6 ions are behaving as oxidizing agent. And it can convert aldehyde into carboxylic acid. It does not oxidize alkene functional group, so A could be correct option. B, a solution containing dilute acidified manganate 7 ions. Now this is also oxidizing agent which can oxidize alkene to diol. So as in this reaction alkene is unchanged, so therefore B is wrong. C, a solution containing hot concentrated acidified manganate 7 ions. Now this can also oxidize alkene to respective aldehyde, carboxylic acid and carbon dioxide. So C is also incorrect. In D we have concentrated sulfuric acid. Now concentrated sulfuric acid can oxidize alkenes to alkyl hydrogen sulfates. It cannot oxidize aldehyde, so therefore D is incorrect. The only correct option is therefore A. Question 29. 4 reactions of propanoic acid to form salts and other products are shown. Which reaction does not show the formula of all the correct products? In the center we have propanoic acid. First reaction is with potassium hydroxide, which is alkali. So we know that acid and alkali form salt. So as it is potassium hydroxide, so the salt will be of potassium carboxylic acid along with water. So this reaction is correct. In second reaction we have acid plus metal, which gives salt and hydrogen. B is also correct, as salt of magnesium is being formed along with hydrogen gas. In C we can see that acid has reacted with sodium carbonate, so acid plus carbonate forms salt, carbon dioxide, and also water is formed. So as all products are not given, so C is wrong. In D we have acid alkali reaction, again salt of calcium along with water is formed, which is correct. So in part C they had left out water, so therefore C is the correct answer. Question 30. Compound X contains 3 carbon atoms. Part of simplified IR spectrum of compound X is shown. Which compound could be X? In this spectra, we can see that there is no peak present between 1670 to 1740, which means carbonyl carbon is absent. So when carbonyl carbon is absent, then it must not be an aldehyde or ketone or carboxylic acid or ester. Second, we can see that the peak is present between 3200 to 3600, which is the peak for alcohol group. A, we have aldehyde, CH3, CH2, C double bond OH, as carbonyl peak is absent, so therefore A is wrong. B is carboxylic acid, CH3, CH2, C double bond O, OH, as carbonyl peak is absent, so B is also wrong. C is alcohol, CH3, CH2, CH2, OH, as no carbonyl is present, only OH is present, so C could be correct, as OH peak is shown. Also, we can see another peak from 2850 to 2950, which is due to presence of carbon-hydrogen bond. As carbon-hydrogen bonds are present, so therefore C is correct. As carbon-hydrogen bonds are present in alcohol, so C shows both these peaks. In D, we have ester, which is CH3, C double bond O, CH3. Again, carbonyl carbon is present, whose peak is absent, so therefore D is wrong. Correct answer is therefore C. Question 31. 1 mole of sulfuric acid is used to make an aqueous solution. The solution contains H2SO4, H plus ions, SO4 negative 2 ions and HSO4 negative ions. Which statement are correct? 1. The solution contains 6 exponential 23 sulfur atoms. As we have 1 mole of sulfuric acid, so 1 mole H2SO4 means that we have 2 moles of hydrogen atoms, 1 mole of sulfur atoms, and 4 moles of oxygen atoms. So as in 1 mole we have Avogadro's constant number of atoms, so therefore 1 is correct. 2. The solution contains an exactly equal number of H positive ions and HSO4 negative ions. Let's write equation for solution of H2SO4. So when H2SO4 is put in water, it forms H positive and HSO4 negative. But now what happens that HSO4 further ionizes in a reversible reaction into H positive ions and sulfate ions. So we can see that we have more H positive ions as compared to HSO4 negative ions. So 2 is wrong. 3. 1 mole of sulfate ions contain 2 moles of electrons. Now in sulfate, the atomic number of sulfur is 16. The atomic number of one oxygen is 8. So in sulfur, 16 electrons are present, while in 4 oxygen, 32 electrons are present. And we also have negative 2 charge. So 16 plus 32 plus 2 becomes 50 moles of electrons. So we do not have 2 moles, we have 50 moles of electrons in 1 mole of sulfate negative 2 ions. As only option 1 is correct, the answer is therefore D. Question 32. Which statements are correct? Number 1. The hydrogen bonds in ice are more regular arranged than in water, as water is liquid and ice is solid. And we also know that in ice, the water molecules are arranged in such a way that there are empty spaces between the molecules. As ice forms crystal structure, so therefore this statement is correct because the hydrogen bonds in ice are more regularly arranged than in water. Number 2, the solidification of water to form ice is exothermic. As we know that this is freezing process and kinetic energy is lost, so therefore energy is released. As we know that this process is called freezing, so freezing is exothermic in nature as kinetic energy is lost by water to form ice. 3. Pure water is less dense than ice. This is incorrect because in ice, empty spaces are present due to which ice is less dense than pure water. As option 1 and 2 both are correct, the answer is therefore B. Question 33. Calcium reacts with water to form calcium hydroxide and hydrogen gas. This is the balanced equation. The standard enthalpy change for this reaction is given, which is -414. What further information is needed in order to calculate the standard enthalpy change of formation of calcium hydroxide? We can rewrite this equation. We have calcium plus water, which forms calcium hydroxide plus hydrogen. Now this equation shows the standard enthalpy change of reaction. Now we can make a triangle if we know the elements that are involved. We have calcium, hydrogen and oxygen. Now these elements can first combine to form these reactants, and these elements can also directly form this product. So according to Hess's law, this will be a two-step process and this will be one-step process. So we can write delta H1 for this step and delta H2 for this second step, which is the enthalpy of formation of calcium hydroxide. As in delta H1, we can see that calcium is present, which is unchanged, so therefore enthalpy of formation will be 0. Second, water is formed, so we would need enthalpy change of formation for water value for delta H1. In delta H2, we have enthalpy of formation of calcium hydroxide, which is to be calculated. And second is formation of hydrogen. As hydrogen is same, so therefore enthalpy change of formation of hydrogen is 0. We don't need the value for enthalpy change of formation of hydrogen. We also don't need the first and second ionization energy of calcium. Because we are not finding the lattice energy, we are finding the enthalpy change of formation of calcium hydroxide. As only option 1 is correct, the answer is therefore D. Question 34. Which statements are correct when a reversible reaction is at equilibrium? Number 1. All species are at equal concentration. Now this is not always true because equilibrium can establish between unequal concentrations. For example, we can have 80% of the reactant present and only 20% of the product, but still the reaction could be at equilibrium. So it is not necessary that concentration must be equal for all the species. Part 2. The concentration of all species remain constant. Now this is true because in reversible reaction, what happens that the rate of forward reaction is equal to the rate of backward reaction. So whatever the concentration of reactant and product is present, it does not change. Part 3. The rate of forward reaction equals the rate of reverse reaction. This is also true for equilibrium state. As both 2 and 3 are correct, the answer is therefore C. Question 35. Each of the 3 mixtures shown can result in a chemical reaction. Which mixtures result in a redox reaction? Now redox reaction is such a reaction in which both reduction and oxidation takes place. First is bromine and hydrogen. The reaction will be like this: Br2 plus hydrogen. The oxidation state is 0 for both as they are in molecular form. HBr is formed in the product. Now hydrogen is +1 oxidation state and Br has -1 oxidation state. So we can see that bromine has shifted from 0 to -1, which is reduction, while hydrogen has shifted from 0 to +1, which is oxidation. So this is a redox reaction. 2 is sodium chloride plus concentrated sulfuric acid. Now concentrated sulfuric acid can react with sodium chloride to form sodium hydrogen sulfate along with HCl. The oxidation state of sodium is not changed. The oxidation state of chlorine is also unchanged. For sulfur, again it is unchanged. So 2 is not a redox reaction. 3. Potassium iodide plus silver nitrate. Now we know that silver iodide is formed along with potassium nitrate. The oxidation states are similar. So this is also not a redox reaction. As only option 1 is correct, the answer is therefore D. Question 36. Which statements correctly describe an oxide of nitrogen acting as atmospheric pollutant? Number 1. Nitrogen monoxide reacts with oxygen to form nitrogen dioxide, which contributes to acid rain. This is a true statement, as nitrogen dioxide is an atmospheric pollutant. Second, nitrogen dioxide reacts with sulfur dioxide to form sulfur trioxide, which reacts with water to form sulfuric acid. This also produces acid rain, so it is also an atmospheric pollutant. This is a correct statement. 3. Nitrogen oxides react with unburnt hydrocarbons in sunlight to form other pollutants. This is also correct because it forms photochemical smog. Which is also atmospheric pollutant. As all three options are correct, the answer is therefore A. Question 37. Polymer Z contains the length of polymer chain shown below. This short length of chain is found many times within the chains of polymer Z, although it is not a repeat unit. This is the chain that is given. What could be the name of polymer Z? First is poly-2-chloropropene. Now the name of monomer is given, which is 2-chloropropene. Propene is the one having 3 carbon atoms, and on second carbon we have chlorine atom. So when it forms polymer, what happens that these 2 carbon atoms are present in long chain, while this will act as a substituent. So it will be like this. This is the repeat unit. With this carbon, 2 hydrogen atoms will be present. As this structure is different than this one that is given, so 1 is incorrect. In 2 we have polychloroethene. Chloroethene is the reactant. In ethene we have 2 carbon atoms, and chloro means 1 chlorine is attached. Rest are the number of hydrogen atoms. So this can polymerize to form this repeat unit. As this is similar, because this carbon contains 2 hydrogen, this carbon contains 1 hydrogen, 1 chlorine. Again this carbon contains 2 hydrogen, and the next carbon will contain 1 hydrogen and 1 chlorine. So 2 is correct. 3 is PVC, which is also called polyvinyl chloride. Now the formula of vinyl chloride is CH2 double bond CHCl. This is also similar to chloroethene, so therefore chloroethene or vinyl chloride will polymerize to form the same product. Three is also correct, as this is similar to this one. As 2 and 3 are correct, the answer is therefore C. Question 38. Limonene is found in lemons. This is the structure of limonene. We have alkene functional group. Also another alkene functional group is present. Limonene is heated with concentrated acidified potassium manganate 7. So what will happen that oxidation of alkene will take place, which compounds are produced. The carbon atoms involved in double bond is this one. As this carbon is attached with 2 alkyl groups, so it will convert into ketone. This is the second carbon that is involved in double bond, as it consists of 1 alkyl group and 1 hydrogen atom. So it will convert into carboxylic acid upon oxidation. Third carbon that is present in double bond is this one. It also consists of 2 alkyl groups directly attached, so third will convert into ketone. Fourth carbon atom present in double bond consists of 2 hydrogen atoms, and then it will convert into carbon dioxide. So we have carbon dioxide as an option. Let's draw the product that is formed upon oxidation. So this carbon will convert into ketone, as this is first carbon. This is the second carbon. It will convert into carboxylic acid. This is the third carbon atom, and it will convert into ketone. And this fourth carbon atom will convert into CO2. Now we can rewrite this skeletal formula into structural formula, starting from this carbon, which is CH3. Then we have carbonyl carbon, CO. Then we have CH2. Then again CH2. Then we have this carbon which only have one hydrogen atom attached, so it is CH. And this whole group is attached with this carbon, which is C double bond O, CH3. So we can write CO, CH3. Then we have this carbon which also has 2 hydrogen atoms, so it is CH2. Then finally this carbon atom, which is carboxylic acid. As only one carboxylic acid is formed, while in this one we can see that 2 carboxylic acids are given, so one is wrong. Third one is exactly the same as the structure given. So 3 is formed. As both option 2 and 3 are correct, the answer is therefore C. Question 39. Chlorofluoroalkanes have been used as the refrigerant in refrigerators, but care has to be taken in disposing of old refrigerators. Which statement about chlorofluoroalkanes are correct? Number 1. Carbon-chlorine bonds more readily undergo homolytic fission than carbon-fluorine bonds. As we know that fluorine is more electronegative, so this bond is more strong as compared to the bond in carbon-chlorine bond. So this statement is correct. Also we can see that this bond can absorb UV light to form chlorine radicals. 2. Care is taken in the disposal of old refrigerators because of possible ozone depletion. Now these radicals that are formed, they can convert ozone back into oxygen. So therefore this is correct. 3. C2H4Clf is more volatile than C2H6. As we can see, we have 2 electronegative elements, so we have partial negative charges present in this molecule. While in carbon and hydrogen, the electronegativity difference is not much, so therefore this is non-polar. Non-polar molecules are more volatile as compared to polar molecule, so therefore 3 is wrong. As option 1 and 2 are correct, the answer is B. Question 40. The molecular mass of compound X is 72. The composition by mass of X is 66.7% carbon, 11.1% hydrogen, and 22.2% oxygen. X gives an orange precipitate with 2,4-dinitrophenylhydrazine reagent. X does not react with Phelan's reagent. What can be deduced from this information? First is that X gives orange precipitate with 2,4-DNPH. It means X can be aldehyde or ketone. Second is that X does not react with Phelan's reagent, as ketone does not react with Phelan's reagent, but aldehydes do react, so therefore it is not aldehyde, it is a ketone. What can be deduced from this information? Number 1, X is a carbonyl compound, as we can see that carbonyl group is present in ketone, so therefore 1 is correct. 2, X is a ketone, again this is also correct. 3, X is butanone. In butanone we have 4 carbon atoms and 1 carbonyl is present. There are 4 carbon atoms, 8 hydrogens, 1 oxygen. The molecular mass will be 12 into 4 for carbon, 1 into 8 for hydrogens, and 16 for oxygen. So it comes equal to 72. As the MR was given as 72, so this could be butanone. Second is the percentage. Percentage of carbon is 66.7%. So carbon equals 66.7 divided by 100 into the molecular mass, which is 72. So it comes equal to 48. As we can see that the atomic mass of carbon is 48 in this compound. So this is true for this percentage. Similarly, the percentage of hydrogen is given as 11.1% into molecular mass of this compound, so it comes equal to 8. This is also true. Third is oxygen. For oxygen, the percentage given is 22.2%. It comes equal to approximately 16. So 3 is also correct. As all 3 options are correct, the answer is therefore A.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.